I didn't check out how many followers I have, but I can tell you that I have like somewhere between 1,500 and 2,000 watches.
1,500?
And 2,000, yeah. So
I want to YouTube.
people have watched the videos that I've done. We're going to I'm going to create another YouTube channel pretty soon for my dogs. Yeah, because we're hoping to have a litter pretty soon, and well, here's the thing: the kind of litter we're going to do is what you call an artificial insemination litter, and what that means is that the father and mother never physically get together. The father's actually going to be, I think he's in Siberia, but he might be in southern Russia. And there's no guarantees that it's going to work. So I'm hoping it works, obviously. I'm going to spend a lot of money to try to get it to work. It's, the male is an awesome male. He's almost all black. He's got a little white on his belly, but he's almost all black. He's huge. He's super athletic. He is loving, he's kind, he loves his family. And at the same exact time, he will tear your head off if you mess with his family. So it's exactly what I like in a dog.
Oh, it's cute.
Yeah, it is. All right. Let me just show you very, very quickly. All right. So here are some pictures of the dad.
What
is
I
he?
can't see anything.
Oh, I haven't seen
I can't even see his face. He's
My
black.
dog
All right.
doesn't hand drawing for some reason.
Yeah, no.
So there's a picture of his athleticism. You can see him running full speed, cutting a corner. He weighs about 160 pounds.
Same.
So he's a big boy. As powerful as he is, as incredibly tough as he is, you can see that he will allow the children in his family to control him. Justice yesterday met Bauer, our puppy. This is a relative of Bauer's, a little bit older.
Wait, how?
There's another picture of
Justice meet him.
Was that justice?
Softball. And this is the you don't want to mess with him picture.
My dog.
So, yeah, Chihuahua, right? Now, so anyway, we are hoping to get that done, but as part of letting the people know exactly what kind of dogs they're going to be getting, it's important, I think, that they see the dogs in action. So they'll see Ziva guarding, they'll see the dogs playing in the backyard. They play rough. They
I look
play
just
really
like your
rough.
dog in the morning. Don't mess with me.
What happens if you mix the dog with the cat?
You can't.
Cat dog.
Well, that's like saying, you know, what happens if, I don't know, tomorrow you go fishing in a place where there's no water. It can't happen.
What if it did?
Well, I'll worry about it if it does. It's something that would never, ever, ever
That'd be cool. But they wouldn't have like a butt though.
happen.
It'd be like cat dogs.
Okay,
You know what I mean?
now. Okay, so. The next thing we need to do is we need to get started on answering these questions, seeing how we are there, and so on and so forth. I have John Fossey to thank for this.
Who's that?
Fousey, Fossey, whatever you call him, Fusey, whatever. He said Happy April Fools as he walked out of the room at the end of seventh period yesterday, and I said, what do you mean? He goes, you'll find out. So I just went to get the magic wand going, and he taped it closed. So, yeah, thank you so much, John. So, no, he has class seventh period, and we finished a little early. They were doing a pretest, so he was working on the pretest, and while he was doing the pretest, he must have stolen my magic wand and taken care of it with the tape. So, okay, here we go. Which of the following is a function? Talk to me. Which of those is a function? A, B, or C? C is a function. Very good. How come A is not a function?
Because you can put.
Vertical line test. Very good. How come B is not a function?
Because you can. Put
Come on, 3 words. Vertical line test. C is a function because as I look through it, Jimmy,
Different numbers.
Jimmy, you with me here, bud?
Yeah, buddy.
Now, you see,
the battery.
Is there a battery?
Oh no.
You broke
Yeah,
it.
there is. The little green light went off.
Oh boy.
It's saying
It's
something on the
saying
board.
You have to click the button on the
Projection.
Oh, projection mode. Oh, it didn't make a squeaky. That's or a dingy. All right, good. All right, so vertical line test fails. Vertical line test fails. Here, I look to see if any of the elements, the domain elements, the guys at the beginning, the X's, if you will, I look to see if any of them repeat, and they don't repeat. Since they don't repeat, that means that it is a function. Okay, next step up. Find the length of the line segment connecting 1, 2 and 3, 4. Angelina, I'm getting worried. You're more worried about things other than the schoolwork. You got to get focused. And what you're doing isn't bad. When you're choosing to do it is very bad. So don't do that. 1, 2, up. 1, 2, and then let's see here. 3, 4. So the question is, what is the length of the hypotenuse right there? So the hypotenuse is across from the right angle. This is 2 and this is 2. I've created a right triangle. What is the rule we always use in a right triangle? Talk to me. Come on. What's the rule we always use in a right triangle? Oh, come on. You guys are so much better than this. It's not even funny. You're starting in the right direction.
Thank you.
Leg squared plus leg squared equals hypotenuse squared. What do we call that?
Pythagorean theorem.
Very good. Pythagorean theorem. Guys, listen. First off, I know you know this. But the second thing is, when you come into a math class where you are supposed to be doing math, and this thing has been done so many times, I don't care if it's the day before vacation. I get that the minute you walked in this room, it was going to be one of the easiest days to distract you. I get that in your head you're saying, man, I just don't want to be here. But the truth of the matter is we're either going to waste the day or we're going to get something out of it. Now you're here, you're not going anywhere. Can we get something out of it?
Yeah.
Can we learn? So that means you got to work a little bit harder. You got to stay focused. The Pythagorean theorem, technically speaking, what most people all across the country would say is a squared plus b squared is c squared. And that's probably how you learned it last year. But remember, I think that's a dangerous way to learn it. One year, what they did was they did a right triangle like this, and they put the c here, the a here, and the b on the hypotenuse. And then nobody drew the arrow across, and everybody wrote this. Because that's what the Pythagorean theorem says, and it was wrong. It was wrong because when I write a squared plus b squared is c squared, I am assuming that the hypotenuse is c. And if I just mess with you a little bit, and I put c in the wrong place, if I only teach you a squared plus b squared is c squared, 95% of students will get it wrong. They did it one year on a state test, and almost every teacher in the school district, almost every teacher in the state, their kids got crushed. My kids, and this is not a brag thing, because there's other things they did better than I did, but my kids rocked this question. Our answers were like some of the best in New York State, because you know that I really don't teach a squared plus b squared is c squared. I mention it, I go through it, because you should see what everybody else sees, you should be able to be aware of it, but we like to do leg squared plus leg squared is hypotenuse squared. And now what happens is, you just look for the legs and you look for the hypotenuse. This leg is 2, this leg is 2, the hypotenuse is x. So I get 2 squared plus 2 squared is x squared. What is 2 squared? 4. Plus, oh, there's another 2 squared, that's 4. And then, since these are on the same side, what do I do? Same operation. 4 plus 4 is 8, so I get 8 is x squared, and I square root both sides. X is radical 8. Okay? Any question about that? All right. So now we get to the next type of question, and we're morphing into review mode. There's really very little new stuff you're going to learn this year. What we're going to learn is a whole bunch of old stuff. It says here, each pair of figures below is similar. Identify the types of motions that are needed. Now with motions, we're talking about translations, rotations, reflections, dilations. What do you need to turn KLM into NOP. What do we have to do to get it there? A rotation and a dilation. Very good. Can you see that we have to spin it and we have to make it bigger? Okay? So this is number one is a rotation and the dilation. What about number two? What do I have to do to number two to get the big one, A, B, C, D, into the little one right there? What do I have to do? Obviously, it's changing size. So what's one of the things I need to do? Hey, it's changing size, changing size, changing size. Dilation. What else is it doing? It's reflection. It's flipping. So number two is a flip, which is known as a reflection. It flips right over this line in between them, and also it's shrinking, so it's a dilation. Okay, number four. Oh. Number four. We've talked about three angles of a triangle now 2 days in a row. This is the third day in a row. Three angles of a triangle are n, n plus 40, and 3n. Is the triangle acute, right, or obtuse? To do this one, what do the three angles of a triangle always add up to? 180. Okay, so, come on, let's get the F. All right, so the first angle is n. The second angle is n plus 40. See, here they are. The third angle is 3n, and again, 180 degrees, because that's what the three angles of a triangle have to add up to. 1n plus another n is what? 2n plus 3n makes? 5n plus 40 is 180. Now I just solved. This should be on cruise control. Send in the ground troops. Die, die. 5n is 140. Divide by 5. N is 28. Okay? Now, it doesn't say that, though. It doesn't say find n. If it said find n, I would be completely done. It says what kind of triangle is it. So now I have to take the n, and I have to plug it back in and figure that out. So this angle here is 28. The next angle is going to be 28 plus 40. What's 28 plus 40? 68. Good. And the last angle is 3 times n, 3 times 28. Now, we can actually do that off the top of our head. What's 3 times 20? 60. What's 3 times 8? 24. What's 60 plus 24? 84. Now, is this acute, is it right, or is it obtuse? It's acute, because all of the angles are acute angles. Okay? All right, so now we get to the next section. Let's turn the page. It says which scatter plot is a negative association. Now, you remember when we talked a lot about slopes? Does everybody remember we talking a lot about slopes? And I think you're going to remember this diagram. Ready? We said, when we talked about slopes and diagrams, and this and that and the other thing, we said that anytime a slope goes this way, it is what? Positive. Can we all, listen, sometimes when you're preaching on a Sunday morning, the whole church is really quiet. We can't have a quiet room this morning. We got to have a little bit of noise here. Can I get an amen?
Amen.
There we go. Okay. This is a positive slope. Talk to me. What is this? Negative slope. What's this slope? Zero slope. Do you remember what this slope is? No slope. Undefined. Right? Okay. Now, with these, we can draw a line of best fit. And yesterday we started speaking about lines of best fit. Line of best fit's really, really easy. All you're going to do is draw a line through the middle of the dots. What did I just say? Draw a line through the middle of the dots. And my line of best fit could be a little different from Stephanie's, which can be a little different from Alexandra's, which can be a little different than Franklin's, and we can all be right. Okay? So here's my line of best fit. I'll tell you why I chose what I chose in a second. Do you see how it's more or less the same number of dots above and below? Right? Like I'm kind of going through these guys here. So there's 1, 2, 3, 4 above, 1, 2, 3, 4 below. That's kind of the best way to do a line of best fit, to draw it so that you split it down the middle and you have roughly the same amount on both sides of the line. Now, it says which one shows a negative association. What does associate mean? That'd be group with, yeah, to be group with. Like, you ever hear your parents say something like this? Because I know I said it to my kid, and I know it was said to me. You will not associate with so-and-so anymore.
No.
Yeah, when you do something wrong and your parents think that it's because you and the kid were together, and you wrecked each other's judgment, whoever's fault it was, they'll just say, hey, you're not going with that kid anymore. You're not allowed near him. Now, listen, association is like a correlation, and basically, the way you tell from the picture is it's a lot like slope. If this was a line, what would the slope of this line be? Positive, negative, 0, or no slope? Everybody? Positive. So this is a positive correlation. Let's look at the one underneath it. Is it possible to draw a line that accurately splits this in half?
Yeah.
I don't think so. I think the line that splits it in half will go this way. And that is a no slope situation. So it's like there's no correlation, okay? We're looking for one that looks like a negative slope, our best chance at looking like a negative slope. So let's go to choice C and see what that is. I do want to draw lines of best fit with all of these. Okay, so the next one says, well, to draw a line of best fit, and if I had to draw a line of best fit here, I'd probably make it look like that maybe. It's all, I know there's a little more on this side, but the ones on the other side are kind of farther away. Maybe you draw it like this one here. Maybe that's a little bit better. Bottom line is, talk to me about, boys, talk to me about this slope. Is this a negative slope? It's a positive slope. So whether it's the bottom red or the top red or whatever red, the point is it's a positive. So it being a positive, it can't possibly be the answer because it wants a negative. And all we're doing is drawing this line of best fit. We're just going right through the dots. So let's do this one here. If I go right through these dots, I guess I'm going to kind of go like right about here. Okay? What kind of slope is that?
Negative.
Negative. So this is the one, choice D, with the negative correlation. Okay? This is the one, choice D, with the negative correlation. Now, what do we got to do next? Now we're going to start doing some studying of formulas, shapes. And you are going to get a reference sheet on your state test. Yeah, you will get this exact reference sheet, and I'm not sure of this, but I'm pretty sure when we take our final exam at the end of the year, which you cannot opt out of, okay, that one you have to take, you will get the reference sheet as well. And if you don't get the whole reference sheet, you'll get all the formulas you need. So, first off, most of the test that you're going to take, the state test, most of the test is on functions. It's on transformation geometry, which is like rotation, reflection, dilation, translation, and then it's also on the vertical angles, the parallel lines, all that kind of stuff, and scientific notation, lots and lots and lots of scientific notation stuff on the test, exponents, okay? There's only a few questions about shapes, and this is the last topic that we're going to cover, and over the next week or so, a little over a week, we're going to study those kind of questions right now. But notice the shapes here: trapezoid, right circular cylinder, right rectangular prism, right triangular prism, right circular cone. And they show you a picture of each one. So if you get a diagram and you're not sure what the shape is called, just match the shape to whatever you have on the reference sheet, and there are some more shapes right there. Okay, notice they give you volume, surface area, volume, and a couple of different volume formulas. So we're going to go through this step by step and show you what it means. All right, let's just remind you of the terms circumference and area. For a circle, circumference means the distance around the outside. And it just showed you, I think, did they give you the circumference formula on this sheet? Yes, they give you both area and circumference. So, it tells you, now what do you think stands for circumference? C equals or A equals? C, obviously. So, this says find the circumference, and here's the formula, 2 pi r. God bless. Now, there are two ways to do this work. One way is to get the answer, God bless, as a decimal. The other way is to get the answer, and here's the phrase they use, in terms of pi. So we can answer it in one of two ways. First off, what does pi equal about, more or less? It is an irrational number, but there's a decimal that's really close to it. God bless you. You and you sneezing. 1/4. It's about 3.14, okay, give or take. So if you didn't know that, write that on your paper. Pi is approximately, that means it's about, notice it's a squiggly equal sign, that means approximately 3.14. Now, here is, by the way, what's the difference between a radius and a diameter? What does a diameter do? It goes what? All the way across. What does a radius do? Halfway across. So this here, is this a picture of a radius or is it a picture of a diameter? Radius, good. Now, the formula calls for r. What do you think r stands for? Radius. What's the radius in this diagram? 4. So, to get the answer, the circumference is 2 times 3.14 times 4. And then I would just multiply those things. I'm going to get 8 times 3.14, which works out to be 25.26. Okay? That's one way to do the problem. But sometimes they say, give me the answer in terms of pi, and that's even better. Let me say that again. When they ask you for the answer, and here's the quotes up here, in terms of pi, that's much better. It just means leave pi in the answer. It means you don't even have to put in the 3.14, just leave the pi alone. So, in this case, the radius doesn't change. It's still 2, it's still pi, and then there's a 4. So, by the commutative property, I can change the order of multiplying. 2 times 4 is what? So this answer would be 8 pi. They're both correct. The top answer, the 8 pi answer, that answer is in terms of pi. If I say leave the answer in terms of pi, that means let pi be a part of the answer. If I say express it as a decimal, that means let a decimal be a part of an answer. Okay? So that's the difference between the two. I would like you to do the second one, but the only thing I'm going to remind you of, and I don't want anybody to yell out this answer, girls. Before you solve, I want one answer in terms of pi, I want one answer as a decimal. But be careful, because you got to ask yourself, is this 24 a diameter, or is it a radius, and which one do you need for the formula? Now, please don't yell that out loud and don't talk. Just do the two answers both ways. One in terms of pi, and one as a decimal. Go ahead. Okay, so now, is that 24 a diameter or a radius? How many people say diameter? How many people say radius? Okay, it is a diameter. Radius only goes halfway. So if the diameter is 24, what's the radius going to be? 12, good. Radius is halfway. So here's the formula, 2 times pi times the radius. So this is 2 times pi times 12. And remember, I said I always think in terms of pi is easier, because you don't have to multiply by a decimal. What's 2 times 12? 24. So this answer is 24 pi. Over here, you're going to get 2 times 3.14 times 12, which is 24 times 3.14, which, what is it, like 80-ish? Yeah. Somebody, oh, we can't. 3.14 times 24, 16, 1, 5, 12, 8, 2, 6, 6, 3, 75.36. Okay? All right. So obviously, that's living proof that in terms of pi is easier. And if they ask you in terms of pi, you should be a happy camper. Yes?
Where the 12 is, I put 24.
Yeah, and you shouldn't do that because the 24 is a diameter. Radius only goes halfway. You need to look at the diagram each time and say, am I getting the radius? Because that's what the formula calls for, the radius, okay? All right, so now we go to number 3. And it says to find the area of a trapezoid. And, you know, at some point you might say, well, I need to present the whole lesson to the class on how to find the area of a trapezoid. But the truth is that I really don't need to do that because you have a formula sheet. Will you turn back to the formula sheet, please? Now, can you find the trapezoid on the formula sheet? Now, what does it tell you for the area of the trapezoid? It gives you the formula. Alan, go ahead.
1/2 H.
A half h and then
Yeah.
b sub 1 plus
B sub 2.
b sub 2. Now, this stands for the first base and the second base. And in the diagram, what do you think the bases are? The bases are the top and the bottom, okay? This is called an upper base, and this is called a lower base. Now, let's just plug the parts into the formula. The area is a half. What do you think the height is in that picture? What is the height? 6. And then, what do you think it doesn't matter which one is base 1 and base 2. What do you think base 1 is, Jason?
You get
How did I get 8?
no A
This here? Because this is a trapezoid, and I looked at the formula because it says find the area. So I looked at the trapezoid figure, and it said A equals for area is, and they gave me the formula. So all I have to be able to do is look it up on the reference sheet. Okay? Now, what is the first base in this problem? 8. Good. What's the second base? 12. So now you just need to do the order of operations. According to the order of operations, what do you do first? Parentheses. What's 8 plus 12?
20.
20. So I get half of 6 times 20. What's half of 6? 3. What's 3 times 20?
60.
60. That's my answer. Okay? So you might have said to yourself, oh my God, this is so hard. But when they give you the formula, it's not hard anymore. So you just look at the reference sheet and go. Everybody try to find the area. Just don't do the perimeter yet. Do the area of number 4, and then I'll help you with the perimeter in a minute.
What is it?
Jay, you with me? Go work.
Why did you use that formula for that? It's not the same type of.
Huh?
Why would you use that formula for this? It's not the same type of shape.
Oh, that's right. It's a parallelogram, not another thing.
It's based on something.
All right, yeah, I'm sorry. I thought it'd be a trapezoid. You should just do base times height on this guy, that's all. All right, we will do more shapes tomorrow. Use that formula sheet on your homework tonight. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos. See amigas. Cheerio. Sayonara. Garusharus. Codifis. Enjoy.